last class, which is what we talked about, simple for loops. So we went over for loops. We also went over while loops as review. But let me start my screen share. And here you go. So I have Eclipse pulled up. Hopefully you can see it. And I'm just going to go over a solution to the homework. And for everyone who submitted, I really appreciate it. And if you submitted it before today, I should have left a comment for you. Generally, the grade doesn't matter. If I see it, I'll just give you 100. But really, the comment is some things I say, whether you did something great, whether you did something that maybe I want you to take another look at. So if you haven't looked at the comments yet, I encourage you to do that. And if I haven't looked at your submission yet, I'll try to do so tonight. As a reminder, the homeworks, I appreciate if you can submit it a little bit early so I have time to look at it. Generally a day before is good for me. Also, in the future, I might have some of you guys present the homework solutions. And if I do that, your solution is great. Don't worry about that. I might have you take care of the screen share, and then we'll step through your submission and you can explain to the class why you did what you did, and maybe I'll ask some questions. It should be not that much of a stress. We're not going to do that today since I didn't give any prior notice for that, but in the future, we might start the class with some student going over the homework solution. But yeah, so for last week's homework, I said that we have a string, and you can see it on here. And the task was to print out the string in reverse order, just basically taking every letter and flipping it around. So instead of reading it forwards, the first letter would be Y, and then L, and then I, so on, it just goes backwards. And so you could have done this with a while loop or a for loop. I've saw both ways. So I'm gonna do a for loop because that's just what I like. So I'm gonna put the template of the for loop here, which we learned last class. So we have for, we have our parentheses, which is going to contain three parts separated by just leave blanks there, our string. To do that, a lot of you remember there's a convenient method called char at. So if we take our string, I stored it in the variable s, there's a method char at. It's the first thing that Eclipse recommends. And what it does is it takes in some index to print out the character at. So I'm just going to call it I, and this is going to be our loop variable, right? So int I, and the first part is where do we start in our loop? Since we want to print out our string backwards, we want to start at the end of our string. And so you could have hard-coded this, but I'm happy to see most of you used the length method of our string to get basically the last index. So we want s.length, and then we have -1. And so maybe someone in chat, can you tell me why I need this -1 for my initialization? Why do I want I to be s.length -1? Why isn't it not just s.length? Why do we have this offset? So hint is we're taking this variable I and we're using it in the char at method. So I see some messages in chat. Yes. So I see some good answers. It all does have to do with the fact that when we index our letters, we all start at 0 instead of 1. And so like, let me just do something in the comments really quick. Oops. If we have a string like A, B, C, D, right? If we think about the index of these letters, I'm just going to separate it out with spaces. The first letter is going to have index 0. The second letter is index 1. Third index 2. Fourth index 3. And so if we're talking about indices, the last index is 3, right? But if we look at our string, and imagine there was no spaces, I just put it there for so it looks a little bit better. The length of the string is 4, right? A, B, C, D is 4 characters. So the length is 4. But again, there's this disconnect. The last index is 3. And so a lot of times when you're doing loops, you might need to like subtract 1. Sometimes you need to add 1. And don't worry if this is confusing. This is actually like a very common things that programmers have to deal with. There's actually a whole term for something called a one-off error. It's so common that knowing whether you need to +1, -1, or do nothing at all sometimes, it's actually pretty difficult, and it's pretty common to get it messed up. And so people have made up a term called one-off error when you have problems like this where you are slightly off. But in our case, again, we want the last index. And so that's going to be the length of the string -1. Then for our for loop, the second part in here is our loop condition. And this is saying, when should we keep looping? And so we want to loop while our index, or so we start at index at 3. We're basically just going to go down, 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 and we want to stop at index 0, right? We want to print out the character at index 0, but we don't want to go further than that. So there's 2 ways you could have written this. You could have done something like I is greater than -1, right? So 0 is greater than -1. That's great. You print out the character at 0, but -1 is not greater than -1, so you'd stop there. You could have also done it like greater than or equal to 0. I personally like it like this, but it's equivalent to what we had before. And finally, the last part of our for loop is just our change. So how does I change in every loop? Well, we want it to start at 3, and we want to go down, 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 right? We want to decrease it by 1 every time. And so mention this, the way we do this is a minus operator, right? So this is our loop. We start at length -1. We loop as long as the variable is greater than or equal to 0. And for every time we loop, we decrease I by 1. And so this will, if we run it, let's see, takes a moment the first time, but you can see it's doing a letter on every line, so it's a little bit harder to see. So if we change this from print line to just print, it'll remove the new line at the end of every thing. And so you can see we've successfully reversed our string, right? So we had good developers practice daily, and now it's in reverse by letter. So that was the homework. For the bonus part, I'll go over that quickly. Some people did it, which is great. But for those who didn't get to it, the only really trick to it that's different from the first part is how to get each word in the sentence, right? Here we're kind of iterating by letter. So we're doing char at, like something like 3, char at 3, char at 2, char at 1. We want to now get each word. So the bonus was to reverse the order of the words, but keep the characters in the same order. So instead of good developers practice daily, we would have daily practice developers good. Right? And the only trick for that was knowing to use the split method. And so the split method returns a string array, call it words, was s.split. And it takes what you should split it on. You can split it on spaces. And what this does is it takes your original string, takes s, and it says, find all the spaces in it. And wherever I see a space, I'm going to chop it up. I'm going to chop it into pieces. And what's left, I'm going to put it into an array. So we chop it up into words, since we're splitting by spaces. And then now we have an array of the words in our sentences. And now we can actually just take the same loop that we had before and modify it a little bit. So now instead of the length of the string, we want the length of the array. So it's going to be words.length. And then instead of char at, we just index into our array. So words. And just to make it look a little better, I'm going to put some space between the part 1 and part 2. Oh, I forgot my semicolons, my bad. So if I run it now, you can see that Well, I'm missing the spaces, but you can see it says daily practice developers. Good. So hopefully you can see the bonus was actually very similar to the original problem. Looping through an array is pretty much the same as looping through a string. The only difference is that with an array, you have this index operator with the square brackets. With a string, you have the char at method. Are there any questions about the homework? That's all I had planned to talk about, but if there's any questions about either part one or the bonus, I'm happy to answer them now. If you have a question, feel free to put it into chat or just unmute and speak up as well. All right. All right, I don't see any questions, so I'm gonna move on from here. What I want to talk about for today's class is still more about loops. So we have one more lesson about loops. Now let me switch over to the slides now. So you should be seeing the slides. We have one more type of loop that's commonly used in Java that I want to talk about, and that's called the for each loop. And so based on the name, you might assume this is kind of similar to the for loop, and we're gonna look at how it's used. But generally, the for each loop is a special kind of loop that's used to traverse an array or other kinds of collections in Java. Really, for most of the examples that we're gonna see are just with arrays. But if you know things like array lists or like things like maps or sets, you can use a for each loop to loop through those as well. It's actually in a way simpler than the for loop that we saw before. We're gonna see it has a lot less components, right? The original for loop that we learned last class has three different things. It has the initialization, it has the condition, it has the change. The for each loop really is gonna have one component. And we're gonna see what the for loop looks like right now. So here we have what the for each loop looks like. And the syntax might be a little bit weird. We might not have seen the colon used before in Java. And maybe you saw it with the ternary operator. These are one of the very few places that we use the colon. So the top is kind of like the template of the for each loop. We say for, and then we have the parentheses like before, and we have the curly braces. The difference is what's inside of the parentheses. You'll notice that there's no semicolons, right? There's only one thing here. We have basically right here, the array that we're looping through. So we said for each loop is basically only used to loop through arrays or other collections of objects. So we have whatever array we're looping through right here. So this is whatever your array is called, right? It might be called X, it might be called ARR. Doesn't matter, it's the variable name of the array. And then we have the colon. And then here we have the type, which is basically the type of the array. So if this is a string array, we'll put string here. If this is an integer array, we put int here, right? And then this var is just a variable name, a new variable name that we haven't used yet. And basically this variable name we can use inside the loop body, and it's gonna take on the value of each element in our array one by one. And so here's like an example that we can see here. So I just first defined an integer array. And here you can see we're filling out the template, right? So our array is called ARR in this case. So you put that here. And then it's an integer array. So we have int. And then we have I is just some random variable name. I could have called this X. I could have called this whatever I wanted to. I could have called it Bob, right? And then inside, all I do is print out whatever I is. And so let me type this out in Eclipse. Let me first make a new class, I guess. And so today is class 2, I'll call it. So if you want to follow along, you can type as I do. I'll also copy the code into chat if you want to just paste it in afterwards. But the first thing was to create our integer array. And I initialized this to a special value. So like I'll just do 1, 2, 3, and then so jump some numbers, like that. Okay. So I make my array, and then I do my for each loop. So I write for. I have my parentheses. I have my curly braces for the body. Inside the parentheses, I have int I have the colon, and I have my array. And so now we did just a system dot out dot int line I. And so now if we run this code, we can see it printed out like this. So really quick, I'm going to ask a question about our for loop from before. So can anyone tell me how we would have done this with our old version of the for loop? I'll put it here, the template for it here. So like this version of the for loop where we have the 3 components and the semicolons. How would we print out the array using this style of for loop from before? Maybe someone wants to just give me what these 3 values are, something like that. All right. Maybe let's take this piece by piece, and I'm gonna call on someone. So let's say, Evan, what do you think we should put in this first blank? Again, we're just printing out the array. We're just gonna print out every number inside the array.
Is that a normal for loop? Or is it the for each loop?
Let's see. I saw you unmute, but I can't hear anything. I think my audio might be a little bit messed up. Let me check something really quick. To test my audio.
Can you hear me?
Testing. Oh, sorry. Okay. I think it's working now.
Can you hear me now?
Yeah. Sorry. I don't know why my audio messed up.
So are you making a for or for each loop?
We're gonna do a for loop. So I want to compare the for each loop that we have with kind of the for loop that we learned from last class.
You put like int I equals 0.
That looks good. Are you comfortable? Do you want to give the other 3 blanks, or I can call on someone else as well?
Int I equals 0.
Yeah. Sorry. Put it there.
Then do I do the others too?
If you're comfortable, you feel free to.
Like I smaller than R.
R.
Yeah. Then
So I want to look at this a little bit. You're close. I think we're missing one thing. Remember, I here is an integer. Right, we declared as an integer. ARR is an integer array.
Dot length.
Yeah, that's right. We want to compare it with the length. And the final blank. Yeah, awesome. Yep, so that's the 3 components that we wanted. And so maybe someone else, what do we put inside the for loop? We want to print out each element of our array. So we have some sort of print statement. What should we be printing out? Awesome. Thank you, Sophia. ARRM. Yep. So I think we're using the variable I. So yeah, good correction. Yep, we just want to index into our array and print out I. Actually, though you make a good point, I'm gonna use a different variable just so it's easier to compare. So here we use I. I'm gonna use J looks too close like I. We use K. So I'm gonna just replace all the I's with K's, just so it's easier to compare the two loops with each other. So I don't have to say I here and I there. But if we look at this, you'll notice that we just have the same output from before. So notice these two loops are functionally the same. They do the same thing, but they look a little bit different. And you'll notice that the top loop, the for each loop, is a little bit smaller, like less typing. And honestly, that's one of the reasons why developers like it. It's a little bit faster to write. You may have already seen this. You might see this a little bit later. But when you're looping through arrays, generally this kind of thing, int your variable equals 0, less than the array length, plus plus, this kind of pattern, you'll do this over and over and over again if you're looping through arrays like this. And so you can just kind of package it together in a more compact form with the for each loop. The other thing, which is either an advantage or disadvantage depending on how you look at it, is that the for each loop gets rid of having to deal with indices, right? And so in our old version, our variable that we create, this k, is really the index of the thing that we're interested in, right? So here we wanted to print out the numbers 1, 2, 3, 6, 9. Really what we're interested in are the values, because that's what we want to print out. But with our old for loop, we have to like first create this variable for the index and then use the index to access the array, and then we get the value that we want, right? The for each loop skips the array, index step, right? By writing in this form, this variable I that we create is now automatically taking on all the values in our array. So the first time it's 1, the second time it's 2, third time it's 3, the fourth time it's 6, and so on, right? And so we don't have to deal with like indexing into the array manually. It's done for us, essentially. Right? This can be an advantage where we don't have to deal with the index, but sometimes you actually do want the index available to you in the loop. So like a disadvantage of the for each loop would be that, hey, if I wanted to print out the index and the value, it's basically really hard with a for each loop. You could do it, it'd be a little bit messy. With this version though, it's very easy because you already have access to the index right here with your variable. So that's kind of comparing and contrasting the normal for loop and the for each loop here. So are there any questions about the for each loop right now? We can maybe see one more example, but before I do that, I want to see if anyone has any questions about how this looks, how this works, how to write this. I know the colon is maybe one of the things that looks a bit weird. Also, by the way, if anyone was talking earlier before Evan, I didn't hear that. So if there were any questions before that I didn't address, sorry about that, but I can answer them now. So, It's a pretty good and like interesting. I mean, also there's some all right, I don't see any questions in chat, so I'm gonna do maybe an exercise. That's almost gonna be building off the homework. So I'm gonna copy some of the code that we had before, namely treating our string. Also, by the way, if you want this code, I'll put it into chat so you can paste it and run it for yourself. But here, I'm gonna take this. I'm also gonna take this. So I want to do maybe two things. I want to basically do what the bonus was, which was reverse the order of the words. But there's an additional step now. In addition to reversing the order of the words, I also want to reverse the letters within the word. So it's kind of a combination of the bonus and the part one of the homework. And what I mean by that is the output that I want in the end is going to be like, I'm going to do it in two steps. So first we reverse the order of the words. Like this, developers, good. So that's just reversing the words. But what I want now is within each word, I also want to reverse the letters of it. Like this. So notice this is not the same as reversing the letters from the start, right? Because if I reverse, wait, is it? My bad, it is the same, but I want to do it maybe in two steps. And so here, the reason why I word it in this way is because I want us to use a nested loop, which is something that we touched on last week as well. Yeah. So this is actually just going to be the same thing as part one. It's kind of a more complicated way of getting there. But the first thing we want to do is kind of go through the words in the reverse order. So there's a couple ways of doing this. We could do it the old way, which was looping through our index and stuff like that. But we can also try doing it with a for each loop. It's actually not going to be the most convenient. Honestly, this is going to be a very kind of roundabout way of getting there. But one thing we could try to do is like reverse the array and then use a for each loop. Thinking about it more, I don't think that's a great idea. It's a little bit more complicated and probably will be a little bit confusing. So let's just do it the old-fashioned way. Here we go. So I'll just copy the thing I had from before actually. So here was reversing the words. Now, instead of printing out just the word by itself, we want to reverse the letters within the word. And so now we basically do part one. Right. And so here, instead of S, we're just doing words I. And instead of S, we're doing words I. So I'm gonna take a moment to let this sit. And I need to change some of these I's to J's. So if we look at what we're doing now, here's an example of a nested loop, which is what we talked about last week. And I said it can be confusing. Yeah. So here, we have an outer loop that what we saw before is just going through our words in reverse order. So within this outer loop, I is the index in our words array. It's gonna start at 3, and then it's gonna go 2, 1, 0. Right? So that's what I does. Then we have an inner loop, which goes through words I, which is gonna be first daily, then it's gonna be practice, then it's developers, then it's good. And it's basically just gonna do the printing out reverse characters like before. So we just take the string and then we do the char at. And so if we run this, this is actually is the same as part 1, where we just have in reverse order, except we don't have spaces. So this is another example of nested loops. And here's another way of thinking about it from before, because individually we knew what each loop did. We saw this in the homework. So the outer loop is going through the words in reverse order. The inner loop is for each word, we're reversing the letters. So that's actually just an example of nested for loops. One thing I'll say is that you can also nest the other loops that we saw before. You can nest any combination of the types that you'd like. You can have a for loop instead of a while loop. You can have a for each loop that has a while loop inside of it. You can do any combination of these things. But maybe just as a summary of the different kinds of loops that we've seen now. Let's go back to the slides and look at this. So just comparing and contrasting the various kinds of loops. I'll talk about maybe why you'd want to use one over the other. So really, the big comparison is between for loops and while loops. When would you want to use a for loop? When would you want to use a while loop? So in general, for loops are very good if you know ahead of time how many times you want to loop for. So for example, the simplest example is, say you want to do something 10 times. A for loop is very easy to write in that case, right? You just have int I equals 0, I is less than 10, I plus plus. And whatever is inside the for loop will go 10 times, right? And so if you have a fixed number, a for loop is very easy to write for that. But even if it's not like a fixed number exactly, for loops can be very easy, like we saw with looping through the letters of a string, right? Because we know the length of it and the loop just runs that many times, right? So it's not exactly fixed. It's fixed whenever we run the program, once we know what the string is. But yeah, so it's that's another case where you want to use a for loop. You know the length of the string, you know exactly how long you're going to loop for. On the other hand, a while loop is very useful if you don't know ahead of time how many times their loop is going to run. For example, maybe you have some sort of program that's taking in, like it's like a quiz program, for example. And for the person taking the quiz to pass, they need to give 10 correct answers. And so you might have like a while loop that's asking the user questions each time the loop runs. And so maybe the person taking the quiz is very good and they get the first 10 questions all right. But it might also be that they mess up a couple times and maybe you have to ask actually 12 times. Maybe they messed up twice, so you need to ask 12 questions for them to get 10 correct. Maybe they're just messing around, purposely give wrong answers, and you have to ask 100 times before they get 10 correct answers. In that case, you don't know ahead of time how many times your loop is going to run. And so a while loop is very flexible in that case because your condition can be like, while the number of correct answers is less than 10, ask a question, right? And then whenever they get it right, you increment that counter, right? So maybe sometimes when you're looping, you don't increment the counter because they didn't get a right answer. Other times you do, right? So the while loop is more flexible in that case. If you were to write a for loop for that, it'd look a little bit more complicated. But again, all these loops have equal power. Anything you can do with one, you can do with the other. It just is a little bit more complicated. And then this slide says the do while, which I mentioned before. A very common use case of do while is user input again, where maybe you always want to prompt once, but after that, if it's not a valid response, you need to keep prompting. Otherwise, if it's legal, then you can move on and don't have to do it again. And then the for loop versus the for each loop. We mentioned the for each loop is just a special kind of for loop where it's only used to loop through arrays or collections. And you kind of skip having the index. And so this can be good if you don't care about it at all, but sometimes you do want the index, and then so you should really use the normal for loop for. So that's really the overview of our 4 different loops that we talked about: the while loop, the do while loop, the normal for loop or simple for loop, and then the for each loop, also called the enhanced for loop. You'll see it online. Are there questions about any of the 4 loops? Why you might want to use one over the other? The syntax, how to write them? Any questions about the 4 loops that we learned about? What does the colon do again? Okay, so that's the for each loop. And let me get my code from before. So this is a great question because, again, the colon is something that we haven't really seen much of before. Only maybe with the ternary operator. And so let's bring our code back. Let's delete this. So I'm also just gonna get rid of this for now because I want to focus on just the for each loop. So the way we use the colon is like this. I like to think about the right side of the colon first. So the right side of the colon is the array that we're looping through. So here I called it ARR, but we could have called it anything else. So if the array was called X, then we'd put X here. Right? If our array was called Bob, we would put Bob here. And so the right side of the colon is the array that we're looping through. On the left side is just a variable. And so whenever we create a variable, we have to declare the type. And so the way we figure out what type it should be is just by looking at the array that we're looping through. So here, Bob is an array of integers. And so we want our variable to be an integer. If this was, I don't know, a long, which is another type of number, we would put long here, right? We just want to match this with whatever the array type is. If it was a double, we would want double here. So I'm gonna put it back to int. And then we have the name of the variable. So here I called it I. If we change this, we would need to change this place. So hopefully this, by going over like this, you can see what's being connected with what. This is connected to this. The type is connected here. And then the name of the variable is connected with the body of the loop. So these 3 different things are connected as follows. And then the colon, I mean, like the purpose of the colon is just what the syntax, the grammar, what someone defined it. Someone just said, this is what it should look like. And that's what we do. It just separates the array that we're looping through and what we're calling each element of the array. Right? And then inside the loop, this just gives access to the things inside of an array. For those familiar with Python, for each loop is actually basically what the Python for loop is by default. So like in Python, you would do something like for x in array, right? And then x becomes every single value in the array. If you're not familiar with Python, don't worry. You don't need to. It's just an analogy if you're familiar. Yeah. Aaron, did that clear up your question, or is there something that's still confusing? Awesome. Are there any other questions from anyone else that I can answer right now? All right, I don't see anything, and I don't hear anything. So with the remaining time then, I want to just go over kind of some extra features that we can do with loops. So these aren't different kinds of loops. We covered all the loops that we're going to do, but here are some extra things that you can do with them. So the first is the break statement. So breaking the loop means that we want to stop the loop early. Maybe it's kind of like maybe you have some sort of condition, and when it's met, you just want to stop, right? You don't want to continue any further. The break statement, what it does is just jumps to the end of the loop, and then it moves on as normal. And then the slide mentions that you might have seen break from switch statements, and it does a kind of similar thing. With a switch statement, the break will jump to the end of the switch statement and execute whatever is afterwards. That's the same thing as break. So for example, here's an example of using break. And so maybe just by looking at this and maybe what I said, does anyone want to guess if I run this, what am I going to see as the output? You can type into chat or you can speak out loud, whatever is more comfortable. But look at this and maybe make a guess. It's going to print it out. So we have two answers, which are the two that I would expect. So Eddie says 1, 2, 3, 4. Ethan says 1, 2, 3. So maybe Aaron says 0, 1, 2, 3. Okay, yes. So I agree. It probably should start with 0, right? Yeah, so it should start with 0. The question now is, does it stop at 3? Does it stop at 4? Yeah. And so I think, yep, Evan and Aaron, your original answer is great. Yeah, it will stop at 3. And the only reason why is because we have the if statement before the print. So if I is 4, we would break. And what break does is it just jumps to the end of the loop. Wherever it was, doesn't matter. It just jumps to the end, doesn't do anything else. It's like immediate. And so we can test this out. We can actually, all right, yeah. I'm gonna leave this, I'm gonna go back to this really quickly. But if we do like our example from that slide, all right, there was no array, my bad. It's just for I equals 0, I is less than 10, I plus plus, something like this. Then system.out.print line or I, my bad. And then if I equals 4, we break. Right. So if we run this, we'll see 0, 1, 2, 3. Yeah. So hopefully that was clear after we talked about it. Why would you need to loop at 10 if you break at 4? Yeah, that's a good question. So the short answer for this is just an example to show what break does. In real life, you would have something a little bit different. Like, yes, you would never write something like exactly like this, where yeah, if you knew we were gonna break at 4, you just would loop to 4 instead of 10. We just made this to have an example of break. Maybe like a more uh, useful example of when you'd want to break is maybe you're looking for some value in your array. So for example, let's look at this. Let's suppose these are some like ID numbers, right? So maybe you have students in a class, everyone has some sort of ID number, and you're looking for someone who has ID 3, right? Then what you could write a loop something like this, right? So you'd loop through your thing, and then maybe you have a variable like bool boolean found. And you would say here, well, if x equals 3, what we're looking for, I'd say found equals true, and then I break, right? Here, what we're doing is we're going through our list and we're looking for some value. And here we're looking for the value 3. And if we find it, we just set some Boolean to true, and then we stop. We stop because we don't care what's in the rest of the array. We were just looking for one specific value. If it was there, it was great. We don't need to look any further. And so we would want to break in this case. This is especially important if you have a really big array with a lot of things inside of it. And in that case, it might actually be expensive to keep going. Again, and this is still kind of a made up example where, yeah, sure, it'd still work if we didn't break. It'd just be a little bit less efficient. But yeah, more examples, like the more complicated it gets, the more interesting it is and the more useful break is. But I don't want to go too far just because I want to introduce this concept of break. Are there any other questions for break? Again, the example on the slide, yes, it's a little bit made up, but actually, I'll say break is a very useful feature to have. I personally use it a lot, especially in cases like this where maybe you're looking for something specific, and once you found it, you can just break. Right? You don't have to need to keep going. Maybe another example is this allows you to write something like while true. Um, you can have a while true loop, which before we would say, oh, this just always runs forever, right? So while true is like, this is really dangerous. We would never want this. But with the addition of breaks, we learned that while true might not actually always run forever. If you have a break in here, that would stop. This would not run forever. And maybe you have some sort of thing where the break is inside some condition, and then it becomes a little bit more useful. Aaron, you asked, how does break work in a nested loop? That's a great question. So in a nested loop, break only exits the innermost loop it's contained in. So if I had 2 loops and I had a break inside the innermost one, when I hit break, I would jump to the end of the inner loop, but the outer one would still continue. Right? So the break works in whatever loop it's written in. There are ways of breaking out of 2 loops or 3 loops or any loop that you want. It's generally like, this is where computer science is a bit of a science and an art, where it's like people don't like that. So there are ways of doing it, but generally it's seen as not good code. It's like not the right way of doing things. If you need to break out of multiple loops, there's probably some other way you could write this that you wouldn't need to do that. But there are ways of labeling your loops. So you can call like the outer loop A, you can call the inner loop B, and then in the inner loop, you can say break A. And that would tell Java is like, oh, I don't want to just break out of the loop I'm in. I want to break out of loop A. Right? And so that's a way, if you wanted to break out of multiple loops, you can do that. But besides break, there's one other thing that we have, which is continue. And continue is a very similar kind of idea to break, where it modifies the flow of our loop, but it does it a little bit differently. In some ways, you can think of continue as a less strong break, right? We saw break just jumps to the end of the loop, skips everything, right? Continue, on the other hand, only skips one iteration of the loop. And what that means is, if you look at this example, right? When we hit the break, what's the next thing that we execute? The next thing that we execute is whatever is below this, right? Whatever is outside of the for loop, written right under it. Right? Continue, on the other hand, doesn't do that. What continue does is it jumps to the next iteration of the loop. So if I was 4 and we said continue, then it would jump immediately to I5. Right? It would skip whatever is inside the body of the loop, but it wouldn't skip everything afterwards. It just skips whatever iteration that you're currently on. Right? So continue is kind of like a weaker break. So here is an example where we would say continue. It's a little bit more complicated, but if we look at what this would do, let's first imagine if we didn't have this if statement in the middle, right? If we didn't have this if statement, what this would do was just print start 0, start 1, start 2, start 3, start 4, start 5, so on until start 9. And then the next time it would break out of the loop, because then I was 10 and do nothing. So is that clear so far? If we ignore the if statement, just pretend it wasn't there, then this would be something we should be familiar with. We can see that it would just do start 0, start 1, all the way up to start 9. Right. If we now put this if statement in, there's a special case if I is 4. If I is 4, we increment I, and then we just say continue, which just says skip the stuff after it, jump straight to the top again. And so what that would do is it print out start 0, start 1, start 2, start 3. And then on the next time it print start, and then it'd say, oh, I is 4. I'm just going to increase it by 1, and then I'm going to skip the printing of it. So it would not print out 4. The next thing it'd do is print start, and then it'd be 5. Right? So we can write this maybe. Check my time, sure. So int I equals 0, while I is less than 10. And then system.out.print line start system.out.print line I. So if we didn't have the if statement, again, oh, my bad, this is an infinite loop. I forgot my I++. We hit play, and you can see it prints out start 0 all the way to start 9. Right? And then if we put the if statement with the continue inside of it, system I++ continue. Get rid of this space. Now, if we look at the output, it looks almost the same, except there's a little bit of weirdness with 4. Right? Do start 3, right? Start 3, then 3 becomes 4, and then we print start again. Let me make sure it's okay. We print start again, and then we skip printing out 4, and we print start 5. Right. So we have 10 start 10 starts printed out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But we only have 9 numbers printed out. 0, 1, 2, 3, not 4, 5, 6, 7, 8, 9. Right. So hopefully this shows what continue does. It skips whatever's remaining in the loop, loop body, but it doesn't exit the loop entirely. Right? It just moves on to the next iteration. That's why it's called continue. It says continue on the next iteration. Right? Don't break, don't exit, just skip whatever's here and continue to the next one. So is that clear for everyone what continue does and how continue is different than break? This example also is a little bit less made up than the previous one, where like you can see how this actually does something different. Whether or not it's interesting, it's not that interesting because it's still an example, but at least you can see like this is not something that we could have done easily without continue. Right? Back to the slides. All right. So just looking at the time that we have left, I have some slides. This will be posted on Google Classroom. This is what I was talking about for labeling loops. So you can give loops a name by putting whatever name you want with a colon before the loop. So here we call the first loop AA, we call the second loop BB. And here you can break out a specific one. Normally break would just break the inner loop. But since we've named them and we break specifically AA, this would skip everything in both loops. But again, this is not very common. I've personally never seen this in the wild. I think it's generally frowned upon, so I would avoid doing this. But it does exist. The only last thing to talk about for loops is that you can have kind of shortcuts. So this is especially true for your for loop, where you have the 3 parts: the initialization, the condition, and the increment. Here, we've basically moved the initialization outside of the for loop. You can do that, right? You can move any of these parts out. You can even move maybe this increment inside the loop body, similar to how we write while loops, right? So as a result, you might see something like this. Looks really weird. Oops, I did one too many. But you can write a for loop like this. So does anyone want to guess what this acts like? Like, what do you think this means, really? The important thing is to think about is like, we have no loop condition, which means that the condition is always going to be true. So that's a big hint of what this is going to do. Like if I put system.out.println hi. Does anyone have a guess of what this is going to do? Okay, yeah, I see some good answers. So Sophia says infinite loop, Aaron says while true. Yep, so this is an infinite loop. This for semicolon is essentially the same thing as a while true loop. And yep, Eddie, yep, it print hi forever. So run this for a little bit. You'll see it's printing at high, it's constantly printing it out. I'm gonna stop it. Yeah, so it's kind of a trick. You will see this every now and then. I guess this is a style thing. Some people don't like writing while true. They like writing for loops. But yeah, so that's a kind of short form of the loop. You can move these components outside if you want. It doesn't have to be inside the loop body. Yeah. So again, here's an example where we just move the initialization, the first part, out. So we don't have anything condition semicolon the change. Right. That's about it for time. So just before we go, we'll go over the homework. So the homework is basically you're given an array of numbers. And I want you to use a for each loop, which is the first thing that we talked about today, to basically go through them. But there's a couple rules I want you to follow. The first is if the number that you're looking at is divisible by 2, skip it. I don't want you to do anything with it. If the number is exactly 99, I want you to basically stop the loop. Don't do anything with that element. Don't do anything with anything afterwards. And then the third rule is if it's not even and it's not 99, then just print out the value. So I want you to use a for each loop. You probably want to use break and continue. There's a little bit more details on the version plus of Google Classroom with like a sample test case and what it should look like. But yeah, that's all I had for today. Thank you for coming by. If there's any questions, and I can take them now. If you don't have any questions, that's all I had, and you're free to sign off for this week. Right. Bye, Jerry.
Thank you.